ACS exam. There are 35 multiple choice problems. They're 2.857 points each. Your score on this exam will be normalized to 50 points by the multiplication of a factor of 1.43. So 35 question normalized to 50. Question 1. What is the IUPAC name for this compound? Question 2, same question. Question 3, which mechanism best represents the E2? Let's give you a mechanism. Give you 4 mechanisms, you pick out the correct one. Question 4. Which pair does not represent resonance structures? Question 5. The non-bonded electron pair on the oxygen atom of blank, gives you a compound, is in what type of orbital? Six. Which compound has the lowest boiling point? It's got alcohols, ketones, ethers. 7. Which carbocation is most stable? Eight. Which statement about the following reaction is correct? And there are questions about the rate. The overall rate is it's first order overall, or it's second order overall. So it's asking you about the rate of reaction. And then it shows the reaction to the right of it. 9. Which of the following energy diagrams depicts a two-step endothermic reaction? Two-step endothermic. Did you guys guess some of these, or you saw them on the side?
No.
You guessed them?
No. The question that you're asking right now? No, I remember from the last
Oh, okay. Yeah. So these are like right off.
Yeah, they come right to mind.
10. Which compound will be most soluble in water? Which is the strongest Bronsted acid? What is the product in the following reaction? It's got two things, this plus this, arrow, question mark. It's got 4 products here. 13. Which Fisher projection represents a meso compound? Which Fisher projection represents a meso compound? And yes. 1. Which structure, and this is a substituted cyclohexane in a chair conformation, which of the following is the lowest in energy? Which structure is lowest in energy? Which amino acid has the R configuration? It shows you 4 amino acids, one of which is an R. It's got proline, cysteine, what's this one? Alanine, and valine. Here amino acids. 16. What is the total number of stereoisomers possible for this molecule? Shows a picture. It's a common one. You guys remember how to do that? Number of stereocenters?
Yes.
Remember that? 17. What is the rate expression for the following reaction? It's got an alkyl halide plus an amine in a polar aprotic solvent. It wants the rate expression. Rate equals K times what? 18. Which reaction provides the highest yield? Of this? Now these are, most of these from here forward are all out of chapter 6. 19. Which substrate is the most reactive in an SN1 reaction? This gives you 4 substrates, one of which is the most reactive in an SN1. What is the major product of the following reaction? What is the major product of this reaction? List the compounds in order of reactivity in an SN2. So it's got 3 compounds here, 1, 2, and 3. And it wants to know, is it 2, 1, 3, 1, 2, 3, 1, 3, 2, or 2, 3, 1? What is the product of the following reaction? It's one that we just covered. H2 and bling. Yes. 23. What is the product of the following reaction? It's another one we just went over. It's got an alkene plus X2. What is the product of this reaction? It's got an asymmetric alkene and a boron reagent. 25. Which reaction conditions will most likely produce the highest yield of alcohol? In which reaction conditions will most likely produce the biggest yield of alcohol? And it gives you a reaction, alkene to an alcohol. 26. Which starting material reacted to the following product? Guys, I got to tell you, this one's ozonolysis. O3. Step 1 is O3. Step 2 is dimethyl sulfide. So look at ozonolysis. Also, there's a question on the sectional exam about ozonolysis. And I may or may not have a chance to cover it. It's very simple. Just look it up. 27. Which of the following reacts fastest in an E1 reaction? E1. 28. Which conditions are most likely to produce the products shown? Make sure you look up osmium, O-S, it's number 76. O-S-M-I-U-M, osmium tetroxide. Look that up. 29. It's probably the only time you'll ever see that element, osmium. 29. Which reagent will best accomplish this transformation? You know, there's 3 of these from chapter 9. I'm going to go over here in just a minute. They are Lindlar's, L-I-N-D-L-A-R apostrophe S. Lindlar's reaction turns an alkyne into a it turns an alkyne into a cis alkene. Then there's a dissolving metal reduction. It turns an alkyne into a trans alkene. And then there's catalytic hydrogenation. It turns an alkyne into an alkane. Those 3. 30. What is the major product of the following transformation? It gives you an alcohol, and it's treated with H2SO4 and heat. Which of the following carbocations is most stable? It's another one of those carbocation stability questions. 32. Has a set of reaction conditions and it wants the product. That's about all I can say. 33. 33 has a molecule and it's treated by NBS. NBS is N-bromosuccin amide. NBS / HNU, light. NBS light. And NBS, when you shine UV light on it, produces Br dots, Br radicals. So this is a radical reaction. 34. What the hell are they asking here? Oh, 34 is an alkyl bromide with a strong base, and the key here is underneath the arrow says high heat. High heat. And last question, 35. Which is the most likely E1 product for this reaction? Shows a substrate with, and then it's got an arrow with silver nitrate and methanol. It wants to know which is the most likely E1 product. So it's telling you what the mechanism is. All right. Draw 2 lines in your notes. This is now the sectional exam. This will go a lot faster. Question 1. This is figure 7.7 in weight. I think it's page 286 still. The relative stability of alkenes compared to ethylene in increasing order is. What's the Zaitsev order? Plain and simple. That's from chapter 7, by the way. 2. Which of the following is not a violation of BREDT, Brett's rule? 3. This molecule, it shows you a Fisher projection. This molecule undergoes a stereospecific E2 elimination. It's the same thing as the extra credit from last time. Yeah, you put it anticoplanar and eliminate it, E2. Question 4. Another E2 question on a ring. E2 question on a 6-membered ring. So it's a bromocyclohexane. And it wants to know what's the E2 product here. That's 4. 5. Five is an EZ question. Is it E or is it Z? Is it Entgegen or Zusammen? 6. How do we measure the relative stability of substituted alkenes? How did we get the Zaitsev order?
All of our stuff is with
7. 7 has a cyclic bromocyclohexane, and then it's treated with a base in acetone, and it wants to know which alkene product, so it's obviously an E2, which alkene product would predominate. It's simple, you pick out the Zaitsev product, thermal substance, yeah. All right, question 8. What reagents could be used to prepare cyclopentene from trans 1,2-dibromocyclopentene? Remember those 2 reaction conditions? Sodium iodide and acetone and zinc acetic acid. Remember those? Yeah. All right. So you get a big anti-dibromo compound. You can treat it with. Question 9. Question 9 has an alcohol treated with H2SO4 and heat. So it's a dehydration question. Dehydration of an alcohol to give which alkene? What is the main E2 product? And it gives you this stereoisomer here. What's the main E2 product? Question 11. Identify the possible products for the alcohol dehydration. Now guys, when it says possible products, what does it mean? Not the major organic product. It doesn't mean that. If it can happen, it's asking you, is this product possible? Okay? So when you're asked possible products, always look to see if there's an all of the above. Because that's usually the answer. Whether it's my exam, MCAT, or some standardized exam, when they say possible products, they're looking for all the possible. 12. According to Zaitsev's rule, which of the above alkenes would be the major organic product? And that question 12 relates to 11, where you identified the possible products. So 12 asks you pick out the major organic. 11 wants the possible products, 12 is the most likely major organic product. 13. It's got a cyclic alkene treated with HBr. And what's the product? 14. Same alkene, exact same alkene, treated with HBr, and below the arrow says ROOR. Yeah, peroxides. 15. Predict the product. It's got an asymmetric alkene, and then it's treated with HGOAC2 in ethanol. So it's an alkoxymercuration demercuration. HGOAC2 in ethanol, and then 2 treated with NABH4. It's alkoxymercuration demercuration. 16. It's got the same asymmetric alkene as in 15. This time it's treated with H2SO4, H2O. Treated with sulfuric acid and water. Predict the product. Use the choices from question 15. 17. Exact same product as 15 and 16. Same substrate rather. Same substrate as 15 and 16. This time it's treated with 1 BH3.THF, 2 H2O2OH. So hydroboration oxidation. Again, use the product choices from question 15. 18. This one's got an asymmetric cycloalkene that's substituted, and it's predict the product of this cyclic alkene after oxymercuration demercuration. Okay, 19 has the exact same substrate as 18. This time it treats it with BH3.THF, and then followed with H2O2OH. Question 20. Why does boron append or attach to an asymmetric alkene in a selective way? (21) 21 is an alkyne. It's being treated with H2 on top of the arrow, on bottom of the arrow, PT. 22 is another alkene treated with the same, under the same conditions as 21. H2PT. 23. It wants to know what reagent or what could cause this transformation. Just make the eraser. I lose it or I lose my mind. Oh. Wants to know how you could do this. 24. The use of, and it's got a structure, and then it's got the name, diazo or diazomethane. D-I-A-Z-O, and then the word methane. Diazo or diazo, I say diazo, diazomethane. Has its drawbacks. Look up diazomethane. You'll see what they are. I almost found out the hard way what they are. 25. 25 is a question about carbenes. C-A-R-B-E-N-E. Carbenes. And it asks you, which of the following is not a characteristic of carbenes? Which is not a characteristic of carbenes. 26. Remember that auto-elimination carbene? Okay, it's a question like that. It's an alkene plus chloroform, NaOH, and H2O. 27. 27 is a S-I-M-M-O-N-S, Simmons-Smith reaction. Simmons-Smith. Okay, 28. 28 it confuses people because it's an internal alpha elimination carbene reaction. So you got to know that mechanism. There's 3 questions in a row on that alpha elimination carbene. 29. 29 is an asymmetric alkene that's treated with Cl2 on top of the arrow, H2O on bottom. Same substrate, this time treated with Br2 on top, on bottom, CCl4. (31) is a hydroboration-oxidation sequence. 32. 32 wants to know what set of reagents could accomplish the following transformation. Starts out with a molecule here, then it has arrows, a couple arrows with question marks above them. And then it's got a product on the right-hand side. Now, the choices are 1, 2, and 3-step syntheses. Remember, simple is better. But it says what could accomplish. So if it could do it, you have to consider that choice. Not necessarily the best one, but one that could do it. 33. That was 32. 33. Got a terminal alkyne that's treated with NaNH2. I'm going to talk about this today. NaNH2 and then an alkyl bromide. Predict the major organic product. 34, same question. Alkynine. Got a terminal alkyne treated with NaNH2 and then it's treated with formaldehyde and water. 35, same question. 3 questions in a row. 36, same question. 4 questions in a row. 37 is straight out of chapter 9. Straight out of chapter 9, it wants to know, it's got a Vic dichloride, a vicinal dichloride, treated with fused, F-U-S-E-D, KOH, and 200 degrees. Just look up those conditions. I can tell you, it creates an alkyne.
Can you repeat that?
Yeah. It's got a VIC dichloride, treated with F-U-S-E-D, fused KOH, 200 degrees. 38. It's got a GEM, G-E-M, dibromide. It's treated with NaNH2 at 150 degrees. 39 has a terminal alkyne treated with NaNH2, followed with treatment with a ketone, and then dilute H3O. There's the 5th question on this alkynide thing. 40, Lindlar's catalyst. 40 is a question about Lindlar''S, catalyst. 41 has a molecule with double bonds, more than one, that undergoes ozonolysis. O3, step 1 is O3, step 2 is CH3S, CH3. Okay, 42. 42 is dissolving metal reduction. D-I-S-S-O-L-V-I-N-G, metal reduction. I'm about ready to put it on the board. 43, treatment of an alkyne with hot concentrated KMNO4. HOT, hot, concentrated KMNO4, potassium permanganate, OH minus, and then it's followed by step 2, dilute HCl. 44. It's got an alkene treated with cold, COLD, dilute KMNO4, followed by OH minus. 45. Remember I showed you guys keto-enol isomerization? Did I show you that? No? I didn't show you HG treatment of alkynes with oxymercuration, demercuration yet?
Yeah.
Okay. It's a question about that. About a vinyl, V-I-N-Y-L, alcohol, A-L-C-O-H-O-L. They tautomerize. I want you to look up tautomerization and tautomers. And be very well acquainted what those mean. Tautomerization. 46 asked another question about this process. Tautomerization. 47. Ozonolysis. That's another question about ozonolysis. And it wants to know the names of the intermediates. Ozonide, malozonide, that kind of thing. It's a sequence in the book it shows you. It produces a sequence of structures. 48. The first step in oxymercuration is blank. That's the question about the mechanism. 49. Markovnikov addition. It asks a question about that. And 50, hydroboration, oxidation. It asks a question about the mechanism. That's about all I can say to describe that one.